All right, welcome. In this video, I'm going to talk through some examples of finding empirical and molecular formulas based on some data. So I'm going to assume that you have read through these definitions up here at the top and looked through this example. And then we're going to skip ahead to going over a sample problem. And so let's take a look down here at substance B. So the scenario here is we're assuming that we have encountered some unlabeled white solid. We don't know what it is. We're trying to identify it. We know maybe it's aspirin, Tylenol, vitamin C, glucose, baking soda. We know it's one of these possible substances over here to the right. And so we're going to use our problem solving steps to figure out what the empirical formula is of the substance based on this data. So we're assuming we analyze the data, we know the percent by mass of the various elements. So we're going to find the empirical formula and then figure out what it is from this list off to our right. So we went over A in class. Let's take a look at B. So if we think about our kind of, our rhyme, our saying for finding empirical formulas, it's percent to mass, mass to mole, divide by small, multiply till whole. So percent to mass, what that means is that I am going to take these percentages I'm given and I'm going to write them down as grams. So instead of 57%, I'm going to say it's 57 grams of carbon, and then 6.16 grams of hydrogen, 9.52 grams of nitrogen, and then 27.18 grams of oxygen. So that's my percent to mass step. And then I'm going to go from mass to moles, which means I'm going to use the molar masses of these substances to convert from grams to moles. And remember, the molar masses is something we find on the periodic table. Okay, so for carbon, it's 12.01 grams, hydrogen 1.008, nitrogen is 14.01, and oxygen is 16.00. So that's my mass to mole step. And when I put in the answers here, I get 4.7569 moles here. I get 6.111. I get 0.6795, and I get 1.6988. And a good rule of thumb with sig figs is you always wait and round until the very end. So I'm not going to round anything yet. I'm just going to hang on to all my digits for right now. So the next step is going to be divide by small. Okay, which means I'm going to look at these numbers I just calculated. I'm going to take the smallest of them, which is the 0.6795, and I'm going to divide everything by 0.6795. This is the step that is most commonly forgotten, so don't forget the step. Divide by small, very important. When you do this divide by small step, one of your values should always end up being 1. If it's not, that means go back and check it again. That means we did something wrong. Okay. And then if we look at these other numbers, for carbon, you end up getting 7.00. So we can round that to 7. The hydrogen, you get 8.99. So we can round that to 9. And then sorry, so that's 9. Yep. And then the last one we get 2.5. Sorry, I got lost in my math there. Okay, this is 2.5 moles of oxygen. And so that is a divide by small. And then sometimes you can just stop here. Like if everything's already whole numbers, then you can stop and you're done with the problem. But if you have a fraction like this, 2.5, that means we need to do that multiply till whole step. So you want to ask yourself, what could I multiply 2.5 by to turn it into a whole number? And you might think to yourself, okay, what if I double it? Well, 2.5 times 2 gives me 5. So that works. In order to keep this ratio consistent, I have to multiply everything by 2. So I'm going to go through this. I'm going to end up with 14 moles of carbon, 18 moles of hydrogen, and then 2 moles of nitrogen. So my formula here is C14H18 N2O5. That is my empirical formula. And if I compare it over here to my options, that looks like that is NutraSweet. So I've just identified that what was in my container was NutraSweet. Okay, let's look at another example where we have to do the next step of finding the molecular formula. So I'm going to scroll down to one of these problems. And let's look at problem number 1 here. So problem number 1, it tells us we have a hydrocarbon. Hydrocarbon means the substance contains hydrogen and carbon. That's it. And then it's 20% hydrogen by mass, and that's all that gets mentioned. It doesn't mention the carbon at all. Well, but we know it's only made of two things, hydrogen and carbon. So if it's 20% hydrogen, it must be 80% carbon. All right. So we've identified our percentages. So first step was we're going to do percent to mass. So we're going to write these out as masses, 20 grams hydrogen and 80 grams carbon. Mass to mole. So we're going to say like 1 mole of hydrogen is 1.08. 1 mole of carbon is 12.01. And you might say, I only have 1 sig fig here. But remember, we're going to wait and round our sig figs until the end. So I'm going to leave a lot of digits in these numbers here. So this is 19.84 moles of hydrogen. This right here is 6.66 moles of carbon. So percent to mass, mass to mole, divide by small. So I'm dividing both by 6.66. So I'll end up with 1 mole of carbon for every, this ends up being 2.98 moles of hydrogen. That's close enough to round. So basically if you're within 0.1, then you're good to round it. So this is only 0.02 away from the nearest whole number. So you're good rounding it there. So that gives me CH3. This is the empirical formula. But I want to know the molecular formula. So the way that we find the molecular formula is first step, and this was outlined earlier in the example. There's an example up here. I'll scroll up and show you again, right here, with ascorbic acid, where we went through this. So first thing you want to do is you want to add up the masses of your empirical formula. So that means I take my 1 carbon and my 3 hydrogens, add those up. So the mass of my empirical formula is about 15. The molar mass has to be given to me in order for me to solve this type of problem. So I'm told the molar mass is 30 grams. So I'm going to take the molar mass, 30 grams, divide it by the empirical formula mass. So I'm looking at this right here. And I'm going to end up with some whole number. So in this case, the number I get is 2. What that means is that the molecule is twice as big as this empirical formula. So I want the same ratio, a 1-to-3 ratio, but I'm going to multiply it by everything by 2. So it is C2H6. So we just double everything. So notice how it still matches the 1-to-3 ratio, and then if you add up the masses in here, you'd have 12 plus 12 plus 6. The masses add up to 30. So that's how you solve this type of problem. All right. Let me know if you have more questions. Thanks for watching.